All right, we are back, and we are in the panel phase. As you saw that great panel on UI development, hope you enjoyed that. Right now we have a panel with the great Jeffrey Snover and Jeffrey Snover and Jeffrey Snover. A panel of one, due to some scheduling issues, which we'll figure out. It could be that they'll show up randomly, and that's, of course, Michael Rees and Mark Rusinovich. But we have here the very special guest, Jeffrey, who is the VP of Windows Server Engineering.
Boy, wouldn't that be great? No, I'm
You're not?
Distinguished engineer.
Forgive me.
Boy, I almost got a field promotion.
Oh, man,
Dang.
I almost promoted him live.
Hey, Steve Ballmer, are you listening?
Actually, distinguished engineer is cooler, man.
Yeah,
it means
I
you're
agree.
still a developer.
So exactly, I don't have anybody reporting to me. So
Excellent.
that's
So,
even
but
better.
you are sort of the, tell us what a distinguished engineer does, since you've mentioned
Okay, well,
the term.
distinguished engineer is like a title, and then I've got a role. My role is lead architect for Windows Server.
Okay.
And a distinguished engineer is just somebody who's got a track record of being able to solve really hard problems that brings the company in a lot of money. That's, that's
Well,
basically
right on, man.
the functional definition of a distinguished engineer.
Awesome. Well, thank you. I appreciate it. Last time we talked was sort of in the PowerShell days, which of course you're still involved with.
Yeah, absolutely.
But talk to me a little bit about how PowerShell, the language, has evolved, say, in the past year.
Yeah, so really exciting stuff. So what we did is we now shift our focus from server being a Windows Server being a operating system for a server to Windows Server being a cloud OS, which is to say an operating system for lots of servers and all the devices that connect those, networking devices, storage devices, etc. Then we shift our focus of what we require out of our management, and in particular out of PowerShell. So PowerShell is a scripting language, but really when you want to manage lots of machines, you want more workflow semantics. Semantics that say, hey, I'd like to perform an operation over a long period of time or across a set of machines which can have failures, right? They can be down, and I eventually still want it to eventually happen. So what we did was we took the Windows workflow engine and we integrated it into PowerShell.
Nice.
So now effectively we've got two execution engines with a common language on top of them.
Nice.
So you know how you used to be able to say function, blah, 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 blah. Now you can say workflow, blah, 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 put the commandlets in it. Now the semantics are different, but the syntax is the same, the commands are the same, etc. And when we see that, we'll hand that off to the workflow engine and integrate it. So extremely powerful stuff.
That's awesome.
We also went and people have tried to use PowerShell in the past. A lot of people have tried it and loved it, but they tended to be more advanced scripters, because basically out of the box, there were 230 things you could do, and after that, you had to get into, roll up your sleeves, write some, manage some .NET codes, talk to WMI, talk to COM, all that stuff.
Sure.
And now, we did two things. One is we dramatically increased the commandlet coverage, like over 2,400 commandlets, and we simplified the language and provided more tooling. So it's now very easy to pick up PowerShell.
Awesome. So this is live. I just want people to know, if you are out there, I know you have to be awake by now. Tweet questions for Jeffrey Snover. Hashtag CH9Live, #CH9Live, however you want to say it. We have distinguished engineer Jeffrey Snover up here. We can go technical if you need to, so come on, ask some questions. You mentioned something in your description, the notion of designing a server operating system to be a cloud-capable server operating system. Now, you mentioned that a cloud operating system will be doing things like managing virtual machine meshes.
Yep.
Because that's really what the cloud is, a bunch of virtual machines, then you have to have
Not necessarily.
Okay, talk to me then.
Yeah. So no, some of the largest cloud properties are not virtual. They're physical.
Okay.
Yeah, so Bing, that's all a set of physical servers. And so you still have a fabric controller, but instead of now using the hypervisor to provision a virtual machine, you use a fabric controller which provisions a physical machine. So clouds are both.
Interesting.
Yeah.
Talk to me a little bit about Windows Server 2012, the cloud operating system.
Yeah, so we went and focused in on being a cloud operating system. That's what I say is the major pivot in this release. We've made dramatic increases and advances in storage, dramatic increases in networking, dramatic increases in virtualization and in management. But the most important change we made was we changed how we thought of ourselves. We no longer think of ourselves as an operating system for a box, a server. We now see ourselves as an operating system for a cloud. And that fundamentally shifts our focus on everything that we do. It changes things. What we do in terms of virtualization, what we do in terms of storage, what we do in terms of management. So for instance, the thing I'm talking a lot about here is this notion of a data center abstraction layer. So, about 20 plus years ago, Microsoft led the industry, or actually worked with other people in the industry, to define the HAL, the hardware abstraction layer. Now, HAL is the unsung hero of the computing industry.
Amen.
It's a thing that offers infinite choice and assurance that everything's going to work, right? That's why you no longer, like way back in the day, you'd see an operating system, you'd say, well, geez, I don't know if it works with this or that or that.
Yeah.
And now you can buy a new version of an operating system and know it works with hardware. You can buy you can take an old version of the operating system and it works with new hardware. And that magic, that infinite choice and surety that things are going to work, comes from this hardware abstraction layer.
Excellent.
So that's great for a single server OS. But now, as a cloud OS, we need the data center equivalent of that hardware abstraction layer.
Wow.
And so we call this the data center abstraction layer, or the DAL.
Wow.
Okay. And so the idea there is, and again, back in the day, those guys had to start from scratch, right? Define a set of standards and schemas to manage things on a device. We don't have to start from scratch. We're leveraging standards-based management to produce this data center abstraction layer. So it's the DMTF and SIM standards. That's why we made a major investment in those technologies in Windows Server 2012, and while we're working with other vendors. So at my session yesterday, we in fact produced, to help the industry adopt standards-based management, we produced an open source implementation of effectively WMI.
Wow.
Yeah. We call it OMI, so there's WMI, Windows Management Infrastructure.
Yes.
We open sourced a version called OMI, Open Management Infrastructure.
Excellent.
We're making that available to the world as of yesterday, source code available as of yesterday via the Open Group.
Wow.
And I showed OMI, we've already got it ported and running in Cisco and Arista switches.
Wow.
And so yesterday I showed using standards-based management to talk to a raw hardware device, because these base motherboard controllers talk WSMAN and SIM.
Okay.
Then the same tools and protocols talk to Windows, and then the same tools and protocols talk to an Arista switch.
Wow.
And this is critical because I'm sure you've seen it. If you go take a look at the major outages in the cloud,
yes.
Every service has them. And when you take a look at them, a very large percentage of them come from misconfigured networks. Okay, and why is that? And the answer is, it's a mess. It's a complete mess. There's a gazillion different vendors with a gazillion different ways to do things. Even within a vendor, they have different ways to do things. It's not very automatable. And so what we want to do is we want to have a standard way to go manage and configure the network.
Awesome. Awesome.
So that's very exciting stuff.
Very exciting.
It's one of the most important transitions we've had in the industry.
Incredible. And technically challenging.
It is.
That's why it's taken so long, right?
Yep.
So we have a question from the live audience. Thank you. With more and more PowerShell integration, is there a movement away from GUI-based server management?
Common misperception. The answer is absolutely no. We, in fact, if you take a look at our new server manager, I don't know if you've seen it.
No.
Oh, it's glorious. No, you got to see it, dude.
Yeah.
It's just beautiful. We really embraced the Metro design principles. We shifted our focus. There's another difference between a single server OS and a cloud OS.
Okay.
Server manager was always, I manage the server, or I could point to that server and I manage that server. The new server manager is, I manage these servers. Okay, so it's multi-machine management, all layered on top of PowerShell and standards-based management.
Nice.
So no, we fully embrace management GUIs. It's what made Microsoft great. We're not backing down from that one whit. However, we are implementing them differently. We implement them over PowerShell and over standards-based management so that anything you can do in the GUI, you can also automate. And that's important because a lot of things you want to do, have to happen on the weekend or at night.
Exactly.
And you'd rather be with your family or out playing soccer with the kids,
yes.
right? And so why run and you don't do that? You go and you automate it. You use the GUI, figure out what it's doing, put that in automation, and then schedule it. But that's the other thing we added in PowerShell: tight integration with Task Scheduler. So you say, hey, at this time, fire this up, perform this, do a workflow. Again, so that you figure this stuff out, and then you just sit up. I like to say, the best admins are the lazy ones, right? Because no, it's true. The best admins are lazy because what they'll do is they'll work their butt off in order to not do any work. Like, man, I want to spend this weekend with my family, so I'm going to work my butt off so I've got automation. And guess what? Once you have that automation, not only do you not have to work this weekend, but the next time it comes up, you don't have to do that, and you don't have to do that. And then when you have a problem, I can say, hey, I've got an asset here, I can help you.
Yeah.
And then guess what? You owe me a beer.
Right on, no problem.
No, it's true. So this automation, you're able to, like you do, if I did the same thing with a GUI, and you run into trouble, what can I do for you? Like, best of luck.
Yeah, give me a call.
But when I produce a script, I can give it to you and you can modify it. And so scripting helps us all collectively get smarter and smarter.
Excellent. Now, just to go back, since we're on PowerShell, this is becoming a PowerShell / Windows Server conversation, which is great.
We can go anywhere, man.
But the thing I want to ask
about PowerShell. We should talk about storage.
We should definitely talk about storage.
Most exciting things.
Now, we actually have another question. And this stuff is all about you guys out in the audience. Ask Jeffrey questions. So is there a limit to the number of times I can remove and add the GUI in Server Core?
Yeah, so just to make sure people are clear on what they do. In the past, you had Server Core, or you had what we called full server.
Okay.
And you chose, and if you got it wrong, you got to start, you clean slate the machine and start over.
Okay.
And so now you can have Server Core, and you can convert it to full server or back again. And in fact, there's something in between called minimal server interface, which is, by the way, we no longer call it full server. We call it what it is. It's a server with a GUI.
Okay.
Right? And you can, in fact, take server with a GUI and remove the shell and IE to minimize your patch surface.
Okay.
But you can go back and forth. And no, there's no limit to the number of times. And by the way, why do we do that?
Yes.
It turns out now the default configuration and our preferred configuration, our recommended configuration, is that everyone runs Server Core. Yeah?
Nice.
As we go and worked with the industry to find out, hey, who's going to work in this environment as is and who has to do work, what we found was that there were a number of applications which required the GUI for installation, but after installation, they ran fine on Server Core.
Okay.
And so what you can do is you can say, oh, I've got server with a GUI, I do the install, then I bring it down to core system, Server Core, and run it.
Nice.
And the benefit, of course, is core system. The reason, why are we doing this? And the answer is, fundamentally, you want a server, right? We have a long-range plan here, right?
Okay,
long-range plan is, you have an application, and we want the server, to support that application. And any bits required to support that application should be installed. And if it doesn't support that application, we don't want it to be installed.
Okay.
Why? Because it's a liability. If the software isn't supporting the application, why is it there? It consumes resources, it has a security exposure, and most importantly, it can be patched. And if it's patched, then there's a chance you have to reboot the server. And we don't ever want to reboot the server.
So, but let's talk about this.
Yeah.
I mean, how big is Server Core? I mean, don't you also want to be able to control the actual size of the server?
Yep, you do.
The code base I'm talking about. There's the amount of memory that's required.
Yep.
Talk to me about how, is Server Core going to evolve maybe where it itself could be modular and smaller for certain workloads where I don't need other core components?
I'll say it this way. I'm not going to announce anything, but smart people think just like you do.
Right on. Gee, right on, man.
Yeah.
So remember to ask questions, everybody. Jeffrey Snover's here, taking a little bit of a side turn. But the name of the panel is Big Data in the Cloud, and I know you can talk to both of those. So I want to ask you this. In your opinion, when you think about gigantic amounts of data, and that's really part of what the cloud is, at least for human-centric computing. I put the data up there, I take data down, ambient data is everywhere, it's growing. We have to figure out how can we make sense of it, analyze it, understand it. There's lots and lots of variables.
Yeah, tons.
When you have tons and tons and tons of variables, you could get into a situation where it's harder to find the right answer. So the question I'm asking you is, what are some of the strategies in place to help us really take advantage of all the data that's out there beyond just for marketing analytics?
Yeah,
to
wow.
help
Boy, what a big
people?
question. Okay, so there's a couple different factors of this, avenues we could go down. So let's go down a few and then we can iterate. Okay?
Excellent.
So the first is, what's really going on here? And what's really going on here is that as an industry, we've started to get good at transforming data into insights,
okay,
and from insights into business advantage. Okay, and as soon as IT can connect, computing with a business advantage, guess what? The checkbooks come out. People start writing checks because the more I invest, the more business advantage I can get, and it becomes like crack cocaine, baby. That first hit is not enough. You want more, 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 and that's what's causing this explosion in data. It's that simple. Okay, so now, okay, great. I want to just write checks and things get better. Well, no, because it turns out our storage architectures have to be different. Hey, I can't just buy additional machines and have it work. Oh, I have to have different algorithms to be able to process things in different distributed systems.
Yep.
And by the way, one interesting thing is a lot of these things don't need the right answer. You need a good answer. When people throw up ads, they're not throwing up the right ad. They're throwing up an ad that has a reasonable expectation that you're going to click on it.
Understood.
Yeah. So, but anyway, so you require different storage technologies, you require different computing technologies, and you require different analytics, algorithms and such. And so it's just such a fascinating area. So one of the things I'm just so excited about is the storage stack in Windows Server 2012. So the thing about this, and this is what differentiates Windows and Microsoft against all the other competitors, because you see a lot of activity in the cloud, right?
Yeah.
And great stuff. Hats off to all the people doing great stuff in the cloud. But in reality, it's a bunch of bolt-ons, right? Well, this is a mess. We'll just bolt on something. I'll compensate for something, etc. And we're taking a different approach. We're starting from clean slate, and we're saying, hey, what do we need to do to optimize for the cloud?
Yes.
Okay? So in the storage stack, we're making fundamental changes at every layer of the operating system to improve our storage stack, from the way we talk to raw disks, right? The way we flush data. Some of these commercial drives, the inexpensive ones, the ones that you say, hey, they're so inexpensive I can buy a gazillion of them.
Yes.
We've had difficulty in the way that they flush data. So basically they lie to us. We say, hey, flush the data. They're like, yeah, I flushed the data. When in fact they didn't flush the data. Well, it turns out in operating system, look, here's a bit of advice. Never lie to your doctor, right? Bad choice. Never lie to your operating system.
Right
These
on.
are bad strategies, okay? But the hardware lies to us. And so we changed our strategy. We just accepted that and changed the way we flush the disk. So now those, will have much higher data integrity on very, low-priced commodity disks.
Excellent.
Next, check disk. I don't know, have you ever had a check disk that can take hours?
Yes.
And some of them can take lots of hours, because we basically had a big curve. Two things. One, we now do on-the-fly detection of errors and correction of errors on the fly for a certain class of errors. And then for the other ones, we basically turn check disk into a two-pass model. One pass leaves the disk completely online as we detect things and we make note of them. And then there's a second pass that will go repair things. And so now, all of a sudden, in the repairs, we take the portion of the volume that needs repair offline, not the entire volume, and the repairs happen like that. So basically, you can have extraordinarily large disk, and the check disk takes a very small amount of time.
So let me ask you this. That sounds great, but check disk is I/O.
Yeah.
And in environments where I really am in I/O intensive already, so my server is sending stuff from the disk down to millions of clients.
Yeah.
How does the system say, you know what, I'm not going to run a scan right now? Or because you don't want to use any I/O to understand what's going on the disk.
Well, this is part of the reason why we did the on-the-fly check disk.
So, but how does that work? I guess that's my long-winded way of saying is, how does on-the-fly check disk work in a running environment?
Yeah, so what that works is, as we access the data and we're processing the metadata structures on the disk, there's a class of problems that we can detect for. So we just made the path a little bit longer to check for those things, and we'll repair them on the fly.
Excellent, man. So we have a couple questions from people.
By the way, I didn't finish. Each layer of the stack gets better and better.
So we're going to get to your questions. We're on the layer number 3 now.
Layer number 3.
Please continue. So we got storage.
Oh, no, this is just the disk
just
and the structure.
Disk. All right.
We have a whole new file system, ReFS. right? Log-based file system. We have stored spaces, so you can say, hey, in fact, I don't know if we're talking about it publicly. Well, there's a large cloud service that we have, which has is prototyping a fundamentally different approach to storage using Windows Server. So they have these clusters with basically, for each server, there's like hundreds of disks, right, attached to this single server, getting phenomenal bandwidth out of this. So storage spaces allows me to go and take a large number of disks and break them up into pools, and then to manage those pools. And then the protocol, SMB 3.0. Oh my God, if you haven't looked at it, you just got to look at it. The amount of quality engineering done at each of these layers, but especially SMB 3.0. So a couple things. First is it's multipath. So if I'm doing a data transfer, Thomas Fenning and Jim Pinkerton did this fantastic demo where they had these two machines and they were doing a continuous data transfer, and they mapped CPU utilization versus bandwidth. And they had a 1 gigabit link on there. So then they went and they connected a 10 gigabit link. And they did nothing other than connect the links. Now, SMB 3.0 is multipath, which is to say it detects whether there are multiple paths between source and destination, and if so, will dynamically use them. So in the middle of this transfer, all of a sudden it says, oh, I got 10 times the capacity. I'm going to use that. And so you see the bandwidth and CPU utilization go way up. Because it requires more data. But then they hooked in a 56 gigabit, 56 gigabit InfiniBand link supporting RDMA. SMB detected that. The bandwidth went right to the ceiling, and the CPU utilization dropped to the floor. Because RDMA, it's all offload. So fantastic stuff. We combine that with continuous availability, so we upped the game. In the past, we had high availability. You know, I'm a client, I'm talking to that server goes down, I detect that failure, I just try again, and another server will come online fast enough that it'll respond, I can succeed. Continuous availability says, no, why should the guy do that? Like, maybe he didn't code it that way. Maybe he's going to detect the error and die. So continuous availability says, okay, when he dies, when something goes wrong, the backup is going to take over so fast that the client is going to get the data he asked for without interruption. They're not even going to know that the failover occurred.
Amazing.
And that required changes at every layer of the stack, fine-tuning of all the parameters of the stack. So just an engineering tour de force in storage.
Absolutely.
Crazy stuff.
I mean, in general, for what you guys have done in Windows Server.
Yeah.
I mean, every time when I first learned about it back at Build, I was just like, wow, man. It sort of stole the thunder a little bit. But let's ask questions from real smart people. How do I decide between moving to ReFS or sticking with NTFS? Are there features that I lose by moving to ReFS? I mean, we should probably discuss the differences between those two file systems.
So ReFS implements, the bulk of NTFS, but not all of it. So, for instance, alternative data streams it doesn't have. Yeah. So, what you'll want to do is you'll want to take a look at the details of ReFS, what it has versus what NTFS has, and then find out, does that meet your needs or not. So, adopting a new file system takes a while for the entire industry to get it, but we're working with the vendors, working through all that. We're being very crisp and clear about what it does and what it doesn't do, and then each person will decide when it makes sense for them to adopt. But some of the advantages are pretty compelling.
So now, as a distinguished engineer, the question I would have is, when you already have NTFS, when you decided that we need to modernize file systems to support the kind of workloads that we think are going to happen in the real world, in fact we know they are, and that we need to be competitive and stuff like that, why wouldn't you just extend NTFS or add features to an already existing file system versus something completely new? So my thinking must be, it's fundamentally different at all levels.
That's essentially it.
Okay, so can we
it's
talk
fundamentally different, and then you try and provide as much compatibility as possible. So we take compatibility just super, super high priority, right? That's what, we got a great set of customers. We want to give them maximal benefit with minimal pain. And so we treat any discontinuity with a great degree of scrutiny. But basically, ReFS allows us to adopt, I'll tell you this, storage in general is going to be one of the most important and dynamic and transformational areas for the next 10 or 15 years, right? From the hardware vendors, some of the things they're doing with esoteric technologies and encodings. I mean, just crazy rocket science stuff. I mean, just crazy stuff. To some of these higher level storage architectures. So you will see a bunch of innovation in this space. And so what ReFS does is it lines us up, delivers a bunch of great benefits now, and provides lines us up to take advantage of some of those discontinuities. So basically what ReFS does is it's constantly doing data integrity checks, right? So instead of saying, oh, you've got to have X numbers of copies of the data, it can do that for you.
So why ReFS? I mean, as in re?
As in reliable. Yeah, I like that.
Excellent.
Redo the FS.
Redo the FS,
no. It's a resilient file system.
Awesome, awesome. All right, questions from humans or virtual humans. How is the performance of storage spaces, which you just talked about earlier, in Win8 Server compared to native disk? Is it a virtualized feature?
Yeah, well, essentially it is. We do have storage virtualization, and it's very, very fast. I don't have the actual numbers. We should publish those.
Excellent.
That's a great question.
Great question. Makins. How would you pronounce that? McAkins.
McAkins.
It's an Irish name, for sure.
Absolutely.
Sprite XP. Will there be a free Hyper-V edition of Windows Server? Will it be easier to set up in a workgroup environment?
Yes, so we announced that at TechEd Orlando. There is a free Hyper-V version of Windows Server. You can grab that. I think we call it the Foundation Server.
Okay.
And will it be easier to set up in a workgroup environment? I'm not sure easier than what. But in the past, again, we had a pretty limited. It's server core based. Oh well, there you go. So why do we feel comfortable recommending server core? And in the past, honestly, it was kind of tough.
Okay.
3 reasons. One was we now have a critical mass of PowerShell commandlets. In the past, we had like 220, 230, and now we got over 2,400.
Nice.
So the number of things that you can manage is much higher. We've got better remote manageability, and the number of roles that run on it are significantly higher. We refactored more of Server to be able to run on it, and Windows SQL Server now runs on it. So that's one of the reasons why we're comfortable. So to the man's question, this Foundation Server was run on Server Core, and so now it's much more manageable and easier to set up.
Excellent. Now you mentioned SQL Server, which I would imagine is a file system takes advantage of the underlying file system.
Indeed.
So let's talk about that. ReFS and SQL Server.
Let's see. I don't know if I'm going to make any news here.
No, you don't want to make.
I don't want to make any news. Well, here's the thing. We work closely with the SQL team, and now you can run SQL databases on file systems. So no one would ever do this in the past, right? The performance was just not there. You always ran SQL on a direct attached storage. And that's why you'd have storage area networks, because they were effectively direct attached storage and gave you the perf requirements. Now, if you have storage area networks, don't worry. We make those a lot better with some of the investments we've made around ODX, offload data transfer, and a number of those are going to support SMB 3.0. So if you made an investment in that space, you're sitting pretty. However, now you have the option to go put your SQL databases on file servers. Using very inexpensive storage technologies.
Wow.
Yeah, crazy.
And they'll scale.
The performance is just crazy up there.
So
we had to change our protocol.
Okay.
Yeah, that was the key.
Are you telling me that you implemented WinFS, man? I'm just kidding.
No, we should.
Bill Gates must be really, really happy to see this.
He probably is.
The transactional file system and the ability to run. But I'm kidding, of course. It's not integrating SQL into the data, blah, blah, blah. Just having some fun. That's really amazing. So what was that, when
He's kidding. What he's referring to is Bill Gates always wanted to have the database be the file system.
Yes.
And he beat us year after year after year after year, beating us. We failed him.
But you guys constantly told him up front it probably isn't possible, but we'll do it because that's what you want.
There you go.
So there's some news for you. No, I'm just kidding. Let me ask you this. One of the things I've noticed is in Windows 7, PowerShell shipped with the operating system, in some sense, it is the way that it does a lot of automatic detection and cleanup for you and runs scripts and stuff like that.
Yeah.
Are there new ones in Windows 8? I mean, have they evolved?
Oh, new diagnostics. I don't know the answer to that.
Okay.
I know that we got a lot more commandlet coverage.
Okay.
I do know that they did update some of those, but I don't know how many new ones there are.
Excellent.
But by the way, that's been crazy successful. Do you remember the days when you used to, what was it, like XP even, I think, said, oh, your network's, broken, would you like me to repair it?
Yeah.
And I was just convinced that button was hooked to a script that said, wait 60 seconds and say sorry. Right? It's just never worked.
I can tell you the answer to that question.
Yeah?
Because I worked on that.
Seriously?
Yeah.
Yeah.
And the algorithm doesn't do that.
Okay. It seemed like
But
it.
it turns out that at least in the XP days, reliably detecting internet connected state was a lot more than calling, Win32 API get internet connected state and look for some, 1 or 0 or whatever the return. I don't remember anymore.
Yeah.
Some weird, some return value. It was interesting to tell people, hey, you're not online, or we lost your connection. And I'm not sure that has necessarily been figured out. I mean, you have to make network traffic.
Oh. But here's the thing: when they switched over and transformed that into a PowerShell diagnostic PowerShell troubleshooter, the first time I was in a meeting and this thing popped up saying that, and I thought, well, I know what's going to happen here, but why not? The triumph of hope over experience.
Yeah.
And I clicked it, and it repaired my network.
Yes.
And I was so shocked. I stopped the entire meeting. It was a room full of executives. I said, guys, stop.
Yeah.
Let me tell you what just happened. And
Awesome.
they're like, really? So it's worked out really well.
So, I mean, because in that sense, the script is basically, one of the parts of the script that I find that always works for me is resetting the network adapter.
Yeah.
Because, wireless goes or something changes my connection to my ISP, my current IP address no longer has any meaning or whatever.
Yep.
But and I have to say, I've really enjoyed the way that Windows is becoming much more automated in the sense of being helpful.
Exactly.
And thanks to PowerShell. Rock and
deal.
roll, man. So we have a question. What is the impact of data deduplication to our backup strategy? Do I need new software? What are the risks of implementing? Deduplication sounds like an IT pro word.
Okay,
what does that mean? Deduplication.
So part of storage spaces, so I mentioned storage spaces, you can take lots of machines and lots of disks and put them together into a storage space. Mm-hmm. And then you can assign attributes to that storage space, like I'd like to do mirroring and I'd like to do deduplication. So deduplication is sort of a background process where we go and say, oh, here's a block of data. Is that block of data repeated anywhere else? And if so, I'll get rid of that one and replace it with a pointer to this one. Okay. And so if you have, the most dramatic example is if you have a directory full of VHDs, mm-hmm. we'll go through that thing and you get phenomenal reductions in data.
Okay.
Right? So you get much more capacity for smaller disks. And in terms of the backup strategy, I don't know what the implications on the backup strategy are. That's a great question. Let's see, I'd have to think about that. I should have Jim Pinkerton here. We should bring Jim Pinkerton on. He can answer that question.
Excellent. You never know, because we have sort of a random schedule, as it turns out, which is good. Riding tandem with the random. Channel 9 Live. Jeffrey Snover, tweet questions. I mean, what's going on here, man? Are you awake? Wake up. So, what's the biggest problem in your mind related to Windows Server and its ability to scale to the cloud, which we're first 5 minutes. Yeah. We're in the first 5 minutes of the cloud computing game.
Yep.
Right? First 5 minutes of the first quarter.
Yep.
There's a bunch of quarters left.
That's a very good point. Yep.
So there's a lot of green room for growth.
Yeah.
You don't necessarily know what the problems are going to be.
Yep.
Talk to me about, as you think about this stuff.
Sure.
What are some of the big problems on your mind?
Yeah, honestly, the big one. So there's lots of ones. We got a pretty good beat on what to do, et cetera, mm-hmm. and we got to go do it. But we have a beat on it. The one that remains the biggest, real hard problem is geo-replication, or how to deal with multiple geographies, right? Which is to say, hey. the cloud, like when I write something there, I want to be sure that it survives. And if there's a Katrina or a Fukushima type disaster, I still want this, to work,
yes.
right? And so the problem is that you have latency. It's one thing to say, well, I'm going to replicate my data here, one part of the country, and then another part of the country. But how do you do that? What are the semantics around that? How frequently do you do that? Do you do it and say, hey, so here's one of the fundamental questions is, when I do a write, when do I return? Sounds simple, but the answer is not, right? So if I do a write when it commits, do I commit to that disk, or what about, do I have to wait until it commits to the other side of the world? Because if it waits to the other side of the world, then I'm going to wait for a long time before it comes back. So dealing with some of those geo-replication issues and what's the right programming models to support that, I think are some of the biggest issues.
Would it be sort of like the problem that we've solved in general with UI programming in the sense of asynchronous?
Go to everything asynchronous. Yep, that's
so I
definitely
just call,
some thinking about
basically
that.
throw that in a continuation and then go then to my other thing. And I'm assuming it's going to get done.
Yep.
But as a programmer or as an IT administrator with the script, so you're going to add in PowerShell, I'll be able to use continuations and.
But here's the issue. Yep, so that's a great approach, but here's the gotchas is, do I actually want to flush it immediately, or do I want to buffer those things and do a bulk transfer? Because guess what? There's dedupe there as well. And caching. I might write, and then I might write the same thing a couple times before it then goes. I mean, that's essentially what caching is all about.
Sure.
So if we have caching in one stack, why wouldn't we have caching across replication, across geographies? So there's a bunch of stuff there. So I guess I'd say, dealing with latency, right? Because that's a law of physics you don't get to negotiate with.
You're absolutely right.
And re-architecting around latency, re-architecting and refactoring everything for COGS. Look, the task is really simple. Windows is going to become the best platform to develop and cloud scale applications, and it's going to have the lowest COGS to run and operate them, which means the highest performance, the highest efficiency, the best operational model. That's why automation is so important. That's why our work on hardware offloads and efficiency is so important, why server core is so important. All these things have a reason.
Oh, of course, absolutely. It's all about the cloud.
Yeah.
Now, it just so happens that I know that at TechEd North America, you had announced that Bing front end, which is a fair number of servers, does a fair number of transactions, is running Windows Server 2012 RC. Rock and roll. How's it doing?
Yeah, it's doing very well. Obviously Bing's a rather important site for us. So why are they picking this up? And the answer is the huge advantages that they were able to get. Performance advantages, operational advantages. They are very, very happy.
Awesome.
I mean, they just are.
And you're probably getting some good telemetry data as well.
Absolutely. Yeah. No, that's a great thing. Yeah, Dave Campbell, superstar Dave Campbell, has this great thought experiment. He says, think in your mind about the top 5 software manufacturers, people who produce software that you can buy and run on your site, okay? And get that list. Everybody might have a different list, but generally the same. Now he says, think about the top 5 websites in the world. And now, think of this. There's only one name that'll show up in both lists, and that's Microsoft, right? Websites, Bing, Hotmail, Azure, and then, of course, Windows, and SQL, etc. And so what we're able to do, we're in a unique position to be able to take the lessons of running these large-scale environments and factor them into the operating system. And so that's what we do. We're working tightly with these various teams to find out, hey, what's working for you? Where's your pain? Really, where's your pain? Oh, okay. How can we address that pain? Oh, what do we have to do to make the operating system do that? Oh, offload data transfer. Okay, great. What about better support for hardware, etc.?
Awesome.
We were thinking about this. Oh, that doesn't really help. Why not? Oh. So we get, it's basically listening to our customers. I'd have to say, the one thing,
yes,
we did two things with this release.
All right. One
was we got really, really good at listening to our customers. We've always listened to our customers, but we really dialed it in. We spent over $10 million and almost a year of planning, going out and talking to various customers, the enterprise customers, as well as our people using us in the cloud. The second one is we really got our engineering system down. So the amount of code that we got out of our engineers and the amount of quality that we got out of those engineers and the level of assurance our testers were able to guarantee we were getting, we just got fantastic productivity. And that's why a lot of people have looked at these releases, Windows Server 2012, and said, how'd you do that? And that's the answer.
Awesome. So we got two more questions from Tweeter World. Tourism Geek, what is the next big thing for PowerShell? Actually, let's end that. We should end on that because we started on that.
Okay.
So let's talk about the Red 3D. So we leave both those questions up. What are the big wins to motivate independent developers to use the cloud? Why should independent developers consider using the cloud?
I like this question. So I always ask the question, hey, are you planning to succeed or planning to fail? Okay, and I think most people say, well, that's a dumb question. Of course, I'm planning to succeed. You say, well, how are you going to deal with that success, right? So when you succeed, that means, people are going to use your service, right? And they're going to say, I don't need, now I exceed beyond one server. I need 2, I need 10, etc. Well, guess what? Running one server is kind of, however hard that is, 10 is not just 10 times as hard, it's much more. And when you say, I've got data centers, and now I want to have geo-replicated data centers, this is, you require some world-class people.
Yes.
Okay? And can you hire them? Do you know how to interview somebody to be a world-class data center operator?
No.
Exactly. And so by leveraging the cloud, you get all those capabilities while you just focus in on your code.
Okay.
And so that's ultimately the big reason.
Awesome.
Yeah.
Great answer. And so, what is the next big thing for PowerShell? I mean, are you going to add... PowerShell really, I don't think it gets enough credit as being a really interesting programming language.
Yeah.
Because it is.
Well, in this version, we actually support the DLR. So,
interesting.
Yeah, so just like Java had their hotspot compiler, we effectively do the same thing as Java, which is to say we monitor how the script is being executed, and we'll do on-the-fly compilation to native code. So it goes very, very fast.
Nice
So
job.
basically now you can write .NET in PowerShell. It's very, very fast.
Wow.
Yeah. So what's the next big thing? Fundamentally, you guys are going to tell us. We're going to go through that planning. We have some things off the top of our head, but ultimately we respond to what the customers need. So we're going to find out what they need and prioritize those things. So we've already heard some interesting things. Better support for sort of ubiquitous support for show script. That's the one thing. Honestly, we screwed up. Server Manager, great thing, but we got the prioritization of show script wrong, and it fell below the cut line. And so this glorious GUI, all layered on top of PowerShell and standards-based management, and yet you can't use the GUI to show you how to automate it. So that was just an error, and we'll correct that.
Easy enough to fix.
I don't know about easy, but we'll do it.
Easy enough, I said.
Okay.
You're right. You already are. You have the code.
Yeah.
Right? But from a programming languages perspective, we're going to wrap up here because I'm interested because you've been on a programming languages panel, remember?
Absolutely.
One of those PDCs with Eric Meyer and company. How do you feel about where programming languages are today in terms of the problems that they need to solve? They need to be cloud-enabled, async, blah, blah, blah.
Yeah, so what I see
that?
is lots of innovation and lots of sloppy innovation. Like some of the things that are happening in the big data community, and people are trying to address the scalability. There's some really creative thinking that is really great for this narrow band and then falls off a cliff. And so that's an area where I think Microsoft does well. We take a look at these things with a little bit longer time frame, and we go and we look at those things like asynchronous programming. Let's see. Instead of just rushing out there, we look and we explore, and then we integrate it in a comprehensive way that is compatible with the past and leverages existing skill sets to move people forward, as opposed to, and by the way, and then has a wider dynamic range, as opposed to something that says, okay, to be successful, everything you've learned, like throw that all away.
Yeah.
Grab this, learn this, and limit your problem space to like right here. Because if it falls out there, then you're kind of doomed. And so what we've seen is people who say, start with the technology, it's really, really awesome, and then and they have to pick up another one. And
Right on.
That's what's the advantage of Microsoft.
It is, man. And it's always great talking to you, Jeffrey. We have to wrap up now because it's time for lunch. And people are going to want to take a look. We're going to give them a live feed of what's going on behind us.
Okay, great.
And we'll be back with a security panel at 2 p.m. CEST, so Central European Standard Time. 2 p.m. We'll be back. Rock and roll.